Second try at this video. OBS has been pretty good, but let me down. Can't get the cameras right, and then when you try to fix it, everything goes wrong. But anyway, so I had already done this video basically, and part of it. So I was reading comments, and so one of Flyora's comments was one of these unannotated links, a blind link. Have you seen this video? And it's a video I did just a couple weeks ago, and I did actually 3 video responses to AB Science's video. 4 hours worth of response video. So clearly that's irritating. That first, you couldn't care to even see if what the channel has done in the last 3 weeks. I mean, you couldn't look at the same date as the video and see if I responded in a couple of days, that kind of thing. But no, and then again, just this idea of just posting a link with nothing, no information. You're just obliging somebody to go look, see what it is, blah blah blah. That's all just a waste of time, my time anyway. I consider it a waste of time, and so it's irritating. So I wanted to reiterate: I'm not here to educate anybody on the subject of physics. I'm here as a professional lawyer, so to speak, as somebody who wants to challenge the real contenders. Okay, I don't want to just it's just this idea of being a gunfighter or something, and every asshole wants to show up and think he's got you or something. You're like, yeah, I don't got time for this crap. Probably not a good, not the best analogy. Try some other analogy. Yeah, I'm looking for the heavyweight championship. So in a sense, I'm looking to fight the people who it means something when you defeat them. And really, the whole purpose isn't to educate anybody. Now, that can be a nice side benefit, is that people get interested in physics and care and all that kind of stuff. But it's not what I'm here to do. I'm here to fix physics. I'm here to argue that they have a phony, fake, fraudulent theory that's just a religion, and they're propping it up as a science, and it's not good science. They've jumped to conclusions on weak evidence. They've committed all the crimes you can commit as scientists. They've not washed their hands. They're doing really bad science, and they should be outed, and it should be fixed. And that's my agenda. So I'm really not here to answer mundane questions that were answered 300 years ago or 700 years ago or some other period of time ago. I'm not here to do the elementary physics. Now, the subject is fundamental and elementary in a sense, but I'm not here to give you an elementary education on what the evidence is and explain why certain things happen and how they happen. Now, like I said, it can be a side benefit. You can glean some of that. But I'm really just not here. I'm not here as a teacher. Okay, I'm here looking to argue competent adversaries who understand some of the vernacular and the basic concepts. They've seen the experiments, or they've seen something else. So they have some capacity to understand what's being argued or stated. Anyway, so that being said, okay, I just prefer people not think of this as a channel intended to educate. It's a channel intended to adversarially demonstrate that conventional science is junk. Alright, I have a question regarding UVA and UVB light. So right away you're using this pop culture kind of jargon that's silly in a sense. Light comes at a frequency. You can have a frequency that's really, really tiny, 1 Planck distance of space, let's argue, so a 0 essentially. Or I can have a very big period or frequency, very long wavelength, and that's it. And so UV light would be somewhere between X-rays, which probably start around 25 nanometers, who knows. And so UV light is somewhere around 25 nanometers to 350 or some kind of number like that. So it's a huge range. So obviously the more it's tending towards the X-ray range, you can understand the more it looks like an X-ray. Well, that sounds even scarier, doesn't it? And the less it looks like an X-ray, the better, right? The more it looks like white light or something. But there's no A and B. All right. I'm trying to avoid as much UV light damage. It's not a sentence. It's not a place for a... It's just not a... It's not well written. And that's another kind of insult. You know, when I have to rewrite your comments to read them, that's sort of you're saying to me, I just couldn't care less. Okay, in Australia, the UV index, like I don't know where Australia is and what Australia's circumstances are in terms of how much light gets to Australia. Yeah, I do. But anyway, is very high with ozone. Yeah, there's lots of places in the world, okay, where there might be a little bit more, but it's only a little bit more. So don't get too full of yourselves. You're not the most UV exposed people on Earth. Anyway. My question is, does UV light travel through the door? I shouldn't have to answer that, right? If your door is only like 3 atoms thick, well, yes, it'll travel right through your door. But if you have any kind of standard door, like you can actually see the thickness of your door, it's going to block it, okay? If your door is as thick as an envelope, yeah, it'll block it. A lot of it. Let's see. And so this is another poorly written. My question is, there won't be any question mark. Does UV light travel through the door and scattered around like gas particles? It doesn't. That's just not written in any way I can understand, but well, I mean I can if I really try. There's at least one part, okay? No, it doesn't go through doors, okay? But it does scatter through substances, and scatter is important to how UV light is a little more vulnerable to being made inert by scatter. So I can explain that perhaps. And so find some use to this, because conventional science doesn't give you any explanations for why any of this stuff happens. Because they keep evading the subjects for which they can't deal with. And one of them is light polarization. They just run away from that one wherever they can. Alright, so first you have to kind of understand that the light is rays. Okay, it's not going to go around corners and stuff unless there's a medium to allow it to do that, and some way for it to reflect. So you have to think about it as, you know, it's just not what they say it is, or what you say it is. Yeah, I mean, I don't even know if they say it can go around corners just by magic, just by bending. Like say if you have the surface of the sun, the first thing you have to understand is, yes, in general, the light just comes off in all directions. But the real thing you have to kind of oh man, so it's got the same fucking resolution problem, and if I try to fix it, I'll lose this video, which is really irritating. This exposure problem. Oh god damn, stinking lousy frickin' settings. I mean, it's just irritating. The settings should stay. I shouldn't have to fix the settings every time I load the damn program. Shouldn't create new ones. Alright, but the real point is that at every point the light's coming off in all directions, mostly because of the fact that it's got to go through, okay, the sun. It's got to go through some measure of atmosphere. And you could argue that when things get hotter, okay, when things get hotter, what's really happening is that the light doesn't scatter as much. It doesn't have as much of that coming out in all direction thing, and it comes out basically straighter and straighter in terms of the angle at which rays can escape the sun, because it keeps pushing the crap further away, and the further away you push stuff, the further away the particles get. Like if I had 5 particles and I pushed them that far away, then you can understand that if they were here, they would be much easier to hit if they're close to the surface than if they're far away. So the further away I push them, the straighter the lines will go, because they don't bang into stuff. So anyway, I don't know if you need that part of this. So scatter is kind of interesting, because the atmosphere is doing the scattering thing, and you see a blue sky and all of that stuff, but they don't really explain why. They just tell you that there's this idea that the particle size matters. So if I have big particles, right, and small particles, if I have big particles, then I don't see any change. That is, the light doesn't go red or doesn't go blue. It doesn't change color. It just stays white light. Like both the red and the blue are affected equally. So the idea is, as I would argue, is what really is happening is you have to keep understanding that red light is big, okay, and blue light is small in its polarization. So, you know, it's half the size of the red light in terms of its thickness. And that's what's really going to dictate technical issues. So you can understand that when there's big particles, the red light there's some likelihood that the light will hit the object and all reflect in generally the same direction and stay red light. You know, it won't be broken too substantially. Or that at least pieces, different photons, red photons will hit, and a piece from one photon will go this way, and then the piece from this one, and a piece from this one. And so there's some hope for the red light to stay intact. But small particles, okay, exactly the opposite in the sense that the blue light will stay intact. You know, it's got a good chance to stay intact when it reflects. And so that's what we see. So when the blue light's coming through the atmosphere, it's reflecting in all kinds of directions, you know, bouncing off these particles. And so we can see the blue light because there's some chance that the pieces of it hit the same particle and go the same direction. And so there's some hope of reconstructing that. Where the red light, because of its size, right, the big red light hits, and half the light hits the particle and the other half misses, and now that photon is broken, and it's getting broken in some kind of really substantial way, in the sense that it's not going to survive too many of these collisions and still be able to recombine it with any kind of phase or any of that kind of stuff. So red light is damaged. So people have this idea that the blue light is more affected by the small particles, but in one sense it's less affected. It's just that it's scattered more. But the red light is substantially affected. And so the trick would be is all the blue light will end up getting scattered as whole elements, and very little of it will get through surviving, because of the fact that it has a small polarization, that it's kind of all or nothing, and there won't be any nothing. There's no way the blue light cannot hit a particle. But more of it is salvaged in the sense that more of it survives the scatter. So more of it goes some other direction than straight, because it got scattered. The red light and the pieces have a small polarization, so you can understand that the more they jiggle around, the harder it is to put something back in the small box. So when you separate the pieces, say a piece scatters off one piece and there's another piece over here, and a piece scatters off that piece and they go in the same direction, it's less likely that you're going to put them back in that tighter polarization. So you have blue fragments, but they're harder to put back together because of the fact that you have to put them back together in the small area of space. Where the red ones, you have a better chance of putting back together because you don't have twice as much space that you're allowed to put them in. When you put the pieces back together in the right frequency, you also get them back together in the right space, the right polarization. So the reds are easier to reconstruct. So, but you can sort of see this. So with a sunset, you can see that the sun is really dull, which means that none of the light's really, a big substantial part of this, the brightness of the sun is gone, right? So you can get that part right away, that you're getting a lot less photons. And they're gone red in the sense that you can't see any of the blue, because the blue got scattered. It either gets, you know, more of it, let's see how to say it. It's harder to put it back together in pieces, so the light that has been bounced around is less likely to be recoverable because you have to put it back into a smaller package. So you don't see the blue light, not because all of it's scattered, but because the stuff that made it through isn't reconstructible. And so that's another reason why it looks kind of like fuzzy when you're looking at the sunset. It doesn't seem as, the sun is bigger, it's all hazy, your resolution is way down. And that's because you're looking at reconstructed photons. You're not looking at photons that made it through the atmosphere. You're looking at photons that are pieces of different photons being re-put together again. You're at one of the little bright bands on the double slit experiment on the fringes. And that's what you're seeing. So there's a ton less light, which is giving you plenty of reason to understand that the light went through a whole bunch of an obstacle course of particles. And the smaller the particles, the more likely it is it's going to look red, because the blue ones aren't going to be put back together again. Now, if I make the particles really big, then it becomes the same equation for red and blue light. You can see lots of the red light can reflect, lots of the blue light can reflect, and how much gets scattered is going to be the same. How much gets broken is going to be the same for the blue and the red, and so then it'll go back to being white light again. You'll end up back with a natural color. But the reason why the size of the particle matters isn't because of the frequency of the light. It's because of the polarization of the light. So they'll keep making equations that, that formalize the relationship between frequency and the size. But the real relationship is the fact that frequency tells you also what the polarization is. And that's the key fact. So instead of saying what the accurate formula would recognize the polarization is the relationship, not the frequency. Frequency just happens to be proportional to polarization. The two are connected. But it's like you can make some argument about this indirect connection, and you're blaming the wrong thing. You're blaming the accomplice rather than the actual person who planned the murder or something like that. The real cause is the polarization. And it just happens that polarization is proportional to frequency, so you can blame frequency and be right, in the sense that you're going to get a correct answer, but you're blaming the wrong precise element, the property that was actually causing the effect is polarization. Am I saying anything else on that subject? No, I think I'll leave it there for now. Yeah. I should have gotten to the timing and all that stuff, but, that's sort of been over it. All right. So maybe that's enough on that. And we'll go to my Ken Wheeler video or something. So let me just reiterate. I'm here to have a conversation with physicists if possible, but at least people who are who have spent some time looking at all the experiments and looking at their theories and their explanations and saying, yes or no, that's good science, that's bad, jumping to conclusions, all that kind of stuff. And, that's really the purpose here. So, I'm not here to explain whether UV light goes through a door. Okay, that answer you can get from any scientist can sort of explain to you, that doors are made of matter and forces like light react to matter. That is, if it's a transparent material, it can pass through. So I can go through all the different materials. Like plastic blocks UV. So you can just have a thin layer of plastic sometimes, and it'll block all the UV light. There's like all sorts of ways you can get around it, and based on just changing something subtle versus how much transmission there is. But there's always, every time you let light in, every time you open the crack of the door, well, what's happening is a bunch of reflected light that's reflected off other objects is going to get in your door, but it's not going around any corners. It's just that it's coming from all over. Just like the atmosphere is scattering light, so it makes it look like there's light coming from all kinds of directions, but it's really the same light that came from the one source. It just looks like it's coming from another direction because it's reflected off of something. And so that's why the whole sky is light. And is because it's a bunch of reflected light. Light that was going someplace else that ended up going to you. So it's just like me putting smoke in the room and then having a laser beam shoot through it. Now you can see the laser beam because it's bouncing off the particles of smoke. Yeah. But I mean, I really shouldn't have to do that kind of level physics to do what I'm doing. It's sort of a distraction to go through the stuff that you could have gotten in 8th grade, you know, kind of stuff. I shouldn't really have to, you know, redo all of that. I mean, even if you're taught by conventional physics, you should have sort of been taught this whole straight line thing, that it's really made out of straight lines. You know, as much as they say it's a wave, there are waves traveling in pretty straight lines. You know, I know it's, you know, that does confuse the subject, but yeah, you still should have gleaned some of that, how important straight lines are in physics. But whatever. Alright, so that's it for the comments. Disappointing, but not much I can do. So I mean, I really haven't gotten any counter arguments to either the gravity argument or the basic, you know, simple explanation for what a photon is. So I can't really, you know, there's not much I can do until I get those counter arguments in some form, and there just aren't in any form. No one has given me a link that they'll say is a credible description of the double slit experiment, and you know, there just isn't any arguments out there. Now the problem with the AB Science video you linked to was kind of obvious, that all he did was read the Wikipedia page. I mean, all he did was go to all the old arguments that are based on completely, you know, ignorant assumptions about what was possible. I mean, Newton just didn't know about atoms. He just didn't know things, and not knowing things made him limited what he could speculate about. But when we know those things, those answers become kind of clear. So that's just sort of bogus. But anyway. Yeah, that's it. So we'll do some of this Ken Wheeler crap. It's just so bad, you know, that it's just worth mocking. You know. So it's on the subject of time, and it's so bad. I mean, just the beginning is so bad. So he's going into this Fibonacci sequence. So time is the number 4. Somehow the number 4 is time. And the rest of those numbers, 1, 2, and 3, are about the Trinity, and, you know, all this religious crap. And it's just, no. This has nothing to do with anything real. This is gingerbread talk and witches.
Being, which is the consubstantiality. This is where the Trinity actually came from.
And all of this crap.
The first 5 digits of the Fibonacci sequence are a Trinity: 1 and 1, 2 and 3, 2 and 3, and 5. That's where the Pythagorean and probably Neo-Pythagorean.
Yeah, you know, this is like, you know, there's 2 ears on a rabbit and there's 2 horns on a buffalo, therefore they're the same animal or something. I don't know. You know, I mean, these simplistic, numerologistic, you know, astrologistic horse shit. Okay, just the tiniest of tangential similarities between systems, and all of a sudden we have to believe it's magic.
Also exists amongst the Egyptians in some obscure texts, but that's where the Trinity came from. But the one thing that people keep asking about is time. And time doesn't exist at all. It exists conventionally.
So there's just no point in talking about it as if it exists as matter. Of course it isn't matter. It's not physical substance. Everybody can figure that out, I think. You know, but so it only can exist as a conceptual idea, as a mechanical thing of sorts that doesn't have physical parts, or you just deal with it as just stating that yes, it has a unique place in the universe, in the sense that it's a byproduct of the fact that the universe has things in it that can't get from point A to point B instantaneously. And because they can't get from point A to point B instantaneously, there is now time. So because things are slower than instantaneous, that's why there's time. But it's not a thing. It's just a byproduct of slowness. I mean, you wouldn't just say, okay, what are we going to call the byproduct of slowness? I mean, yeah, you can call it something, but it's really not a something.
But it doesn't exist absolutely at all. All human beings are in a perpetual dream state. That sounds...
So this is silly talk, right? I mean, we have the word dream because it's completely a different state than the active conscious state. So it has some similarities with the active conscious state, but it's distinctively different in the sense it's silly and stupid and, you know, made up, and it didn't really happen. It's just our brain replaying tapes in kind of funny ways, you know, mixing them all up and screwing it all up. But, you know, it doesn't, you know, we know the difference. There's no point in saying we're dreaming when we already know we have a word for dreaming, and this isn't the word.
It's like a passage from the movie Poltergeist. Sounds reminiscent to the...
A passage from? I didn't know. That was a great script, huh? Oh, I didn't realize. I thought it was just say, we're here, or they're here, or some kind of crap like that.
But, I mean, this is true. Dreams don't exist at all, but when we're in dream.
I mean, of course, they exist at all. They're real events in our lives. Our neurology is behaving just as if it was in some ways, you know, actively participating. I mean, clearly you don't, there's so many things missing. It's such a simplified version of the reality, and obviously too, your brain has been broken in the sense that you don't do logic very well. I mean, you're fooled easily into thinking preposterous things are normal.
Dreams, they seem incredibly real, but for waking beings, the dream is time. Time does not exist.
All right, the dream is time. Time doesn't exist, though. So, I mean, how can people watch this crap?
Ultimately at all. Time is not a thing.
Right, well, you said that 17 times, but it's obviously an event taking place. It's a function that we're all being part of. And it moves time, okay, the slowness, okay, is happening progressively. Everything is moving, every material thing in the universe, every bit of force, you could argue, is all on a voyage somewhere, and we're voyaging with it.
Time's brother, if you will, and also, too, the number for space.
It's brother, if you will.
Or kura, or ka, space. The word for space is the brother of time.
So nothing, space. So space isn't doing anything. It's just part of the fact that there is actually small things and big things, and there has to be something between these things, or they can't be called things. If there was no distance between things, then you wouldn't be able to identify them as things.
You say one is a brother, one is a sister. The incommensurate twins.
Whatever.
Things that are unreal, of mass and magnitude. But
okay, of mass and magnitude. So two words that are really important in terms of realness. Mass and magnitude. And they're just unreal. Just like time and space. Mass and magnitude is just like time and space. No, it's hot is the same as cold. No.
The time doesn't exist ultimately at all. Human beings...
So again, it's a simple concept, time. Again, I don't know why this is at all... Why anybody ever had a problem with this one. I don't get it. When I was a kid, I had a problem with clocks. Okay, because I wanted to know why clocks knew what time it was. You know, because it seemed pretty amazing that this stupid piece of wood with this little thing in it, somehow it knew what time it was. I didn't know it was just mimicking time. I thought it was actually telling time, like somehow it knew how to tell time, and I had to know how it did that. So I broke a lot of clocks. But that's really different than this horse shit.
Portion time as far as past, present, future, now, instant, blink. These, of course, are conceptual subdivisions of measure. Related.
They're not just conceptual. They're conceptual in the sense that we are conceiving of something that is a real event. Okay, the fact is that it does take time for the universe, for stuff to move. And now it's at a place where it's all in a certain position, and it's going to be in a different position tomorrow, and we're having to wait for that to happen. It's happening to us just like the universe is happening to the universe. It's all just happening, and the future isn't here yet. The new positions aren't here yet. We have to wait for them. And the past ones are gone. They're not in those positions anymore. Those positions are no longer positions in space where something is.
Always to magnitudes, and that's all time is. Time is a measure of the passage of magnitudes. And
so isn't that, I just don't know how anybody, I don't know how anybody can listen to that crap and say that makes sense. I don't know. I don't understand.
Masses, when we have masses, we have magnitudes. This is the reason why human beings are also too puzzled by black holes, or what we call black holes.
What you call, what they call. Who cares? The idea of matter being in the same place is really stupid. So electrons are in the same place as another electron. No, that's retarded. There are no black holes. There's just heavy stuff and light stuff.
Not actually black, and they're not holes at all. What they are supermasses that have no magnitudes. But we
have more just rubbish talk. I mean, that doesn't mean anything. Supermasses that have no magnitude. So the bigger you get, the weaker you get, until you're as weak as space, and then you're nothing, and then you're time, and then you're four.
Have no parallel for that here on Earth. Human beings don't understand what a supermass with no magnitude is. But that's where dielectricity overthrows magnetism.
So again, there's no dielectricity. There's a dielectric. There's the idea of making an insulator, of various capacity to insulate, and that would be a dielectric. But there is no dielectricity. There is no electricity that is different than that electricity. All the electricity is the same. Electricity is a concept of where atoms exchange electrons, and that's all there is atoms exchanging electrons. There is no such thing as a dia exchange.
Ability to keep anything within the visible universe. As a little aside reference, we have no parallel to compare it to, but if you understand field theory very clearly and lucidly, understanding what the phenomenon of a black hole is extremely simple.
Whatever. I mean, heavy small thing I can understand. Titanium versus, goose feathers. But this horseshit.
If you have moderate to severe rheumatoid arthritis, Enbrel helps relieve joint pain and helps stop joint damage.
Money. So he's doing his metaphysics with a bunch of commercials in it.
Analogously, in a very crude analogy, time is the dangerous flight of... imagine if we were to... Everyone's seen a mechanical clock face, the minute hand and the hour hand. Well, imagine a clock face the size of a small town, and you're sitting on the clock face. Time is the dangerous flight of the hands on a clock.
All right, so now that's just such a terrible metaphor on top of a metaphor. I mean, just circular metaphoring now. Clocks make time, and time makes clocks, and I don't know.
For which the metaphysicians, and all forms of monistic metaphysics, both Greek and Indian, always point to the axial point. It's that point at a clock, which and don't take the analogy too far, is causing the movement of the, possibly a second hand also, a second hand, a minute hand, and the hour hand. The metaphysicians are always pointing to the axial point, which is unmoved, or the unmoved mover. or the nexus of the hourglass. We all know an hourglass shape.
I mean, just all these little vague connections, between the fact of what, turning rotation, into, different variants of velocity based on distance, and, turning that into some sort of magical concept.
Which, by the way, is a hyperboloid. We actually have the movement of sands from the top to the bottom. So we have movement on both ends. We have the antinomies of movement, where we have what happened.
Yeah, you have move the sand up, okay, into more gravity, and then watch it fall. That's all you have.
Has occurred, has passed, what is, and is also occurring, the future, but the center of which would be the point of counter space, where time does not exist. We can.
All right, so there's no time in counter space. So if you ever get to one of these counter space places, nothing happens because there's no time. Okay, fine.
Never measure time in an hourglass from an indivisible point, and point, of course, is also purely conceptual.
No, it isn't really. I mean, it really isn't just purely conceptual. I mean, it really isn't. Yeah, just in the sense there's 3 dimensions. We can know that. And in that 3 dimensions, you can understand you could subdivide it into smaller and smaller and smaller bits. And they sort of have already established that every bit of it seems to be, it stops. There's a place where you get, that's the smallest bit. Like the photon, for example. The things, you can't get something smaller than. And that's as small as it goes. There's no smaller force. There's no smaller bit of movement. There's no smaller blah, 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 blah.
Counter space. Nor could we ever judge time on a clock. If you actually had a clock where you ripped off, in a fit of anger, the hour, second, and minute hands, where you just had an axle point, the clock is still working. Nobody could tell time. Time wouldn't exist. And of course it would still exist just because the clock.
So it wouldn't exist. It would still exist. Obviously the clock is not the timekeeper. It's just not the timekeeper for the universe. It's just mimicking the process of the time passing and giving us some notion of, yes, another inch of space, was moved through. It's just giving you a measure of how far, something standard like a photon would travel in this much time. And it's just giving us another measure of that we can relate to, because we can't really appreciate, how far a foot at the speed of light is.
Faces are not present, so don't take the analogy too far. Nobody could tell time. Time is only the movement and measure.
Well, again, of course we can tell it, and we can tell it lots of different ways. We could measure how far a galaxy spins. If we could live forever, we could watch galaxies turning, and we'd know that's one measure of time. And then we can watch the solar system spinning, and that's another measure of time. And then we could just watch the sun rotating or something, and that's another measure of time. So there's lots of places for us to see the facts that the universe is just progressing through moving distance at the speed of light. That's the fastest thing that, all we got is the speed of light. And the fastest thing in our world, in the universe, is actually really slow. It's just that we're moving so much slower than it is that we don't appreciate that it's incredibly slow. Compared to instantaneous, it's infinitely slow.
Of magnitudes.
Well, it isn't really infinite, right? So I shouldn't say that. It's a Ken Wheeler habit.
Doesn't exist ultimately whatsoever at all. Time is made up of, by the way, you have to think about this for a second, but this is the standpoint of monistic metaphysics, all of the Greeks and Indians. Time is made up only of future and past only, which are wholly unreal. And
so they're wholly unreal, but we call them something because they have properties and because they are something we can define and describe as different things. The past is something you're not going to, and the future is a place you're going to. That's it. But yeah, the present is kind of, fudgy, because it's just where the future turns into the past, just where the future turns into something that isn't going to anymore.
Said time doesn't exist, it's only a measure. Now,
whatever, it's not only a measure, it's a function. It's happening in the universe because everything in the universe is moving slower than instantaneous.
Was not part of now or the present. You know, you have these silly little groups that are always talking about be here now. Well, samsara is just an unbroken chain of present moments. But now is not part of time at all. For
whatever, samsara. Anyway, enough of this, right? I mean, this is just such gooey mush. Ugh. Alright, so that's enough of a video. We'll just surrender. Keep it brief today and just... I mean, there's a point where I just, should just walk away until, I can find some courageous physics people willing to defend their physics. And they're not just complete pussies and, and whatever. But, what else can I do? $1,700, a lot of money. Can't get one of these idiots to take it. Ken seems so greedy, so horny for money. You think he would, inquire. Yeah, but we'll see. He wouldn't be very good because obviously he's not conventional physics. And his audience has to be just so retarded. I mean, so profoundly retarded. To eat this crap. I mean, 698 thumbs up to 20 thumbs down. I mean, that's just disgusting. For just tripe crap. Mush. Ugh. So, enough. I'll give up on this video. Poor exposed video. Poorly. This exposure isn't right on this camera. Just irritating. Anyway, till the next time and such. And so forth and whatnot.